So let's talk about when we have to convert between mixed numbers and fractions. Now, back in the olden days, we used to call those fractions improper fractions, but today they just call them fractions greater than 1 because, hey, there's nothing improper about a fraction. So let's say we have a mixed number like you see here, 3 2/7, but we need to show it in purely fraction form. We're going to do this by breaking it down and then putting it back together. Really, it's not that different from the old school shortcut. It just shows the thinking and helps us see exactly what's happening. We get right into the guts of the math here, and I love that. So I've got 3 2/7, and what I'm going to first do is think about it as an addition expression of 3 whole and then 2/7 more. I can further break it down by taking that 3 whole and breaking it into single units, 1 plus 1 plus 1, and then that 2/7 more. So now it's time for us to take those single, that 3 whole, and bring it into a fraction form. Now, the thing to keep in mind here is we want to take a look at the denominator of in our mixed number. We've got sevenths, so we're going to keep everything in sevenths. If I'm going to convert 3 2/7, then the fraction I am going to create from that or change that into is going to be sevenths. So I ask myself, how many sevenths are in 1 whole? Well, the answer is 7/7. It's the whole. So that 1 whole becomes 7/7, and, well, the next one, that's 7/7 too. And even the next one, 7/7. Now my 2/7 again just gets tacked on at the end, same as it always was. It's already a fraction, so no big deal. So now I have to say to myself, okay, self, how many sevenths do I have? Well, I have 7/7 plus another 7/7 is 14/7 plus another 7/7 is 21/7. And 21/7 plus 2/7 is 23/7. 3 2/7 is equivalent to 23/7. The number's not greater or smaller. We didn't really change it. All we did was show it in a different way. Now, back in the old days, we would have just said, well, you take the denominator and you multiply it by the whole number, and then you take the product of that and you add the numerator, and that will be the numerator of your converted fraction. Well, true, and that is basically what we just did, except for the way we did it shows the math. It's more mathematically sound. It has the why as well as the how. Now let's take a look at this from the other end of the equation. Let's say we start with a fraction greater than 1, like 14/5 right here, but we need to express it as a mixed number. Honestly, this is probably more useful than the last example because you're more likely to need to convert into a mixed number. We just use them more than fractions greater than 1. So what we're going to do is going to look a lot like the backwards version of what we just did when we went from mixed number to fraction. So here's my fraction, and I have 14/5. What I want to do is group out all of the whole numbers I can, and in this case the whole numbers would be represented by 5/5 because remember, we're going to look at that denominator to figure out how we're going to count. So in this case, I can see if I have 14/5, I can pull 5/5 out of that. And that's going to leave me with 9 more fifths. Well, if I have 9 more fifths, I can pull 5/5 out of that. So now I've pulled 10/5 out of my 14/5, which means I've only got 4/5 left. I'm not going to be able to get any more whole numbers out of it. So you can see 14/5 represented on the left, and if you look on the right of the equal sign, we've still got that 14/5. But now we're trying to be able to create that mixed number, which means we're going to take these 5/5, and we're going to say, okay, what's that look like in whole number world? Well, it looks like 1 and 1, because 5/5 is 1 whole, and then that 4/5, we're just going to carry it over because there's nothing to change there. From here, it's simple addition. 1 plus 1 is 2. 2 plus 4/5, 2 and 4/5. 14/5 is equivalent to 2 and 4/5. Now, of course there's a shortcut. There's always a shortcut. The shortcut is a good how, but it's nice to see the why. It's important to understand what's happening when we go from one end of this equation to the other. The quickest shortcut is simple division, and it's not too complicated. You just have to remember what to do with ye old remainder. So let me show you. Let's say I start with that same 14/5. If you know that every fraction can be seen as a statement of division, then you may know that 14/5 is the same as saying 14 divided by 5. So if I take that 14 and I divide by 5, I know that I can get 2 groups of 5 out of 14, and that leaves me with a remainder of 4. Now, the interesting thing about that is, instead of saying 2 remainder 4, which is sort of the old school elementary way, we take this 4 out of a possible 5, and we say 4 out of 5, oh, that's 4/5. We show that fractional remainder as the other part of our mixed number. I can use either one of these methods. The thing to understand is the method in pink, it shows us some how, but the method in white shows us what's really going on when we convert from a fraction to a mixed number. And I'll be honest with you, that's the math. That's mathematics. The stuff in pink is kind of mathematics. It's more like following directions, though. And sometimes that's important, but if you're trying to learn math, the math is important. So go do some math. It's good for you. It's awesome.